deep inside a Webb spectrum, one faint line at 606 wave numbers should not exist. It is the fingerprint of a molecule being destroyed above a moon, wrapped in orange haze. What Webb found is not weather. Titan is losing its sky. The rain may be too late. Look at Saturn through a good telescope tonight, and you will see a small, unremarkable dot beside its rings. That dot is Titan, the largest moon in our neighborhood, bigger than the planet Mercury, and until recently, hidden behind a wall of orange haze that no camera on Earth had ever fully penetrated. On November 4th, 2022, and again on July 11th, 2023, the James Webb Space Telescope and the Keck II telescope in Hawaii turned toward that dot together, and they used something extraordinary to see through the smog. Not visible light, infrared, wavelengths our eyes can't process, but that slip through Titan's atmosphere, like a needle through fabric. What they saw is the reason you are reading this. For a moment, forget everything you know about weather. Now build Titan in your head. It is a world the size of a planet, spinning around Saturn, 900 million miles from the sun. The surface temperature is negative 180 degrees Celsius. The air is nitrogen, like Earth's, but 4 times denser at the ground. There are mountains, dunes, rivers, seas, and clouds. There are seasons that last 7 Earth years each, and there is rain, actual rain, falling from actual clouds, filling actual lakes. But the rain is not water. Water at those temperatures is a rock. The rain is liquid methane and ethane, the chemical cousins of natural gas, cold enough to burn your lungs from the inside. Titan is the only other place in the entire solar system where you could walk to the shore of a sea and watch storms roll in. The maps of those seas exist because of Cassini, the NASA-led mission that spent 13 years circling Saturn between 2004 and 2017. Cassini's radar cut through the haze and revealed something no one expected. Titan had oceans, not tiny puddles. Full oceans, mostly concentrated in the northern hemisphere. Kraken Mare, Ligeia Mare, Punga Mare, names given to bodies of methane that rival the Great Lakes of North America in size. And Cassini gave us the model. The model was beautiful. Methane evaporates from those lakes, rises into the sky, condenses into clouds, and falls again as rain. A hydrological cycle, but the wrong liquid. A weather system, but powered by hydrocarbons. It was the most Earth-like discovery ever made off Earth. Every planetary scientist trusted it. There was only one problem. Cassini could see the seas, and it could see clouds in the southern hemisphere, where it happened to be summer, but the North kept refusing to cooperate. When Cassini's mission ended in 2017, the northern lakes had never been caught in the act of being refilled. We could see the reservoirs. We could not see them being resupplied. That is what Webb was hunting. On July 11th, 2023, Webb's near-infrared camera pointed straight down at Titan's north pole. Days later, Keck II pointed at the same spot from Mauna Kea. The images looked almost identical, bright fuzzy patches at mid and high northern latitudes, clouds, clear, unambiguous, evolving clouds. And when the team compared the pictures taken over several days, something moved. The clouds had risen, not sideways, drifting with the wind, the way a normal Titan cloud might crawl across the disk, vertically, higher into the atmosphere. That vertical motion has a name: convection, the same process that stacks thunderheads over Kansas in July, drawing warm, moist air upward until it condenses and falls as rain. Convection had been observed before over Titan's south, never over the north, not once. Not by Cassini in 13 years, not by Hubble, not by any ground-based observatory, until now. I want you to hold that in your mind. Somewhere, above lakes larger than Lake Michigan, on a moon so cold that human skin would fracture in seconds, columns of gas were climbing into the sky in exactly the same way rain climbs into a storm cell on Earth. Different chemistry, same physics. And if those columns collapse, what falls is a chilly, oily rain onto a ground made of ice, hard as granite. The first response from cautious scientists was the correct one. Are we sure? Could this be a processing artifact? A trick of Titan's ever-shifting haze? A misinterpretation of shadow and infrared filter? Two independent telescopes on opposite sides of the world had photographed the same rising features on separate days. It was not a glitch. Something real was moving in that sky. But when the team ran the same night's data through the mid-infrared instrument, they found something else. A single faint emission line that Cassini had never seen. And that line did not belong to any cloud. The line sat at 606 wave numbers. In practical terms, that means light with a wavelength of about 16.5 microns, deep in the mid-infrared, invisible to human eyes, and to almost every telescope humanity has ever built. Webb's MIRI instrument was one of the first machines sensitive enough to record it clearly. When the team ran the identification, the answer came back fast. CH3, methyl. Now hold that name in your head for a second, because it is doing something impossible. Methane, the molecule this whole moon is built around, has one carbon atom and 4 hydrogens. Methyl is what happens when you rip one of those hydrogens off. It is a fragment, a broken piece, a molecule with an unfinished bond that wants desperately to grab onto anything nearby. On Earth, methyl exists for milliseconds inside flames and lab experiments before it is annihilated. You cannot bottle it. You cannot store it. The instant it forms, it reacts. And Webb saw it in Titan's upper atmosphere, glowing, present, in enough quantity to leave a fingerprint on a spectrum taken from a spacecraft parked 1.5 million kilometers from Earth. That means one thing, and only one thing. Somewhere above those beautiful rising clouds, ultraviolet light from a distant sun and energetic particles funneled in by Saturn's magnetic field are right now tearing methane apart faster than it can regenerate. Webb did not photograph a weather system. Webb photographed a slaughter. Go back to the clouds for a moment. Reinterpret them. The columns lifting into Titan's north are not just meteorology. They are the visible bottom of a chemical assembly line. Methane rises from the seas. Sunlight breaks it apart. The pieces recombine into ethane, propane, acetylene, benzene, and eventually the sticky orange gunk called tholins that gives Titan its color. That process is running around the clock, and every methane molecule broken up above is a methane molecule that will never return. So the obvious question, the one Connor Nixon and his co-authors at NASA Goddard, at the Institute of Astrophysics of Andalusia, and at 6 other institutions could not avoid, is this. If methane is being destroyed constantly, where is the replacement coming from? Start with the boring answers. Comets. Comets are dirty snowballs full of methane and other volatiles, and they occasionally slam into moons. Could Titan's supply be topped up by cometary impacts? The calculation has been done. The delivery rate is roughly 100 times too low. Comets are not the answer. What about the seas themselves? Kraken Mare alone holds more liquid hydrocarbons than every known oil and gas reserve on Earth combined. Surely evaporation from those lakes explains everything. It explains the cycle we can see. It does not explain where the liquid in the lakes came from in the first place. Evaporation just moves methane from surface to sky and back. It cannot manufacture new methane. What about buried reservoirs? Cassini's radar sounded the ice crust for years. There are dune fields the size of continents, mountains of frozen organics, empty basins that may once have held seas, and nothing obviously bigger than the surface pool. we already know about. Nothing that could last 4.5 billion years, because that is the number that matters. Titan is 4.5 billion years old. It formed with the rest of the Saturn system when the solar system itself was young. And if you take the current rate of methane destruction that Webb just measured, and you run the clock backward, the answer is brutal. The methane in Titan's atmosphere today should have vanished tens of millions of years ago, at most 100 million. Titan is 1% of the age at which its sky should already be gone. That is the twist. The atmosphere you are looking at, the one raining onto the northern lakes right now, is not the atmosphere Titan was born with. It cannot be. Something inside that moon, something we cannot see through the ice, is either topping it up right now, or Titan is dying, and we are watching the last chapter. Which brings us to the fluorescence. Alongside the CH3 signal, Webb's near-infrared spectrograph found something else glowing in the upper atmosphere: carbon monoxide, carbon dioxide. Both were expected. Neither was expected in the pattern they showed. The emission lines were coming from an atmosphere that is not quite in thermal equilibrium, meaning energy is being pumped into these molecules by processes we do not yet fully model. Carbon dioxide on Titan is strange. Titan's atmosphere should not have free oxygen at any significant level, and yet oxygen is showing up in these molecules in the exact chemical pathway that on our own planet produces the raw ingredients of life. That was the moment the story stopped being about weather. It was becoming a story about chemistry. And chemistry, at this scale, on this world, was starting to look uncomfortably familiar, because there is one place, and really only one, where the methane could be hiding: under the ice. For decades, planetary scientists have suspected that Titan is not solid all the way down. Cassini measured the moon's shape as it swung around Saturn, and the numbers came back wrong for a rigid body. Titan was flexing. Something inside was moving, sloshing, giving under Saturn's enormous tidal pull. The best explanation was an ocean, not a methane ocean like the ones on the surface, a water ocean warmed just above freezing by tidal friction, buried under 100 kilometers of ice. We have never touched it. We have never sampled it. We have never seen it. But every gravitational hint we have says it is there. And if it is there, then Titan has two liquid layers, a methane rain cycle on top, and an actual water ocean underneath, separated by a shell of ice. Now imagine what could be leaking between them if organic molecules from the surface, tholins that fall like snow after the atmospheric chemistry finishes its work, are slowly making their way down through cracks in the ice. They eventually reach liquid water. Warm liquid water. Complex carbon molecules meeting warm water is not a small thing. It is the exact recipe that most origin of life researchers believe started every biology on our planet. And on Titan, that recipe may have been simmering, gently, in the dark, for 4 billion years. That is speculation. I want to be careful with that word. The subsurface ocean itself is not speculation. Cassini's gravity data all but confirm it. Cryovolcanism, the idea that ice-covered moons can vent liquid or slushy material through their crust, is suspected on Titan, but not confirmed. The idea that some of that venting could resupply the methane in the atmosphere is one of the leading hypotheses, but the evidence is indirect. And the possibility of biology, chemistry so complex, it starts to look like life, is a hope, not a finding. But the CH3 line changes the weight of that hope, because that faint emission at 606 wave numbers is not just proof that methane is being destroyed, it is also the first step in a chain. Methyl combines with methyl to make ethane. Ethane and its siblings build heavier hydrocarbons. Heavier hydrocarbons become aromatic rings. Rings become tholins. Tholins fall. Tholins sink. And if the subsurface ocean is there, tholins meet water. Destruction, at Titan's altitude, is also construction. The moon is burning its own sky and using the ash to build organic chemistry more elaborate than anything else in the outer solar system. That is why NASA is not letting this rest. In 2028, a nuclear-powered rotorcraft called Dragonfly is scheduled to launch. 6 years later, in 2034, it will land near a region called Selk Crater, where impact heat may have long ago melted the ice and mixed surface organics with liquid water. Dragonfly will fly, in Titan's thick air and low gravity, hopping between sites, sampling the ground, measuring the atmosphere, looking specifically for the fingerprints of chemistry that leans toward life. Everything Webb saw is the setup for what Dragonfly is being sent to answer. Now come back with me to the beginning, to that single faint line on the spectrum, to the clouds rising above Kraken Mare on July 11th, 2023. You know what they mean now. Those clouds are real. That rain is real. But every drop that falls onto Titan's ice is a drop that came from a supply that should not still exist. Every methane molecule that evaporates and rises is a molecule marked for destruction. The candle is burning at both ends. The wax is somehow being replaced from below, and nobody knows for how much longer. So let us answer the title honestly. Did James Webb see Titan for the first time? Not literally, no. Webb had looked at Titan before, and Cassini looked at Titan for 13 years. But Webb was the first instrument in human history to catch Titan's northern rain cycle in motion and to detect, directly, the molecule that proves the rain cycle is destroying itself. In that sense, yes, Webb saw Titan, as it truly is for the first time, alive and dying in the same breath. And is something raining? Yes. Cold methane and ethane, falling onto ice that ranks harder than granite, filling seas larger than any on Earth. It is real. It is happening now. And the something that is falling is only half of the mystery. The other half is what is rising to replace it. Titan is either the most patient world in the solar system, quietly refilling its own sky from a hidden ocean, or it is the loudest countdown we have ever heard, a moon spending the last 100 million years of an Earth-like atmosphere, while we finally have the instruments to watch. Either answer changes what we think a livable world means. Either answer suggests that the ingredients of biology can wait in the cold for a very long time. We do not know which one is true. Not yet. What is under Titan's ice, the source that kept the sky alive for 4 billion years, or the emptiness that means we are watching an ending? That is the question Dragonfly is flying toward, and that is the question a single line on a Webb spectrum at 606 wave numbers first taught us how to ask.